Hey guys, I'm here at the school, back for another video for you guys here. What we're going to be working on today is making the other side foot peg mount for my racing motorcycle. So this is the right side foot peg mount. It is also the brake mount. So we're going to be making this. This is out of steel. The stock one is steel, and we're going to be making it out of aluminum, much lighter, okay? And it's going to look a lot better. So what I've gone and done off camera is got my stock material cut to the right length. It ends up being 6.577 inches long, which is longer than what our calipers can measure. So I had to go ahead and use the height gauge on the surface plate to scribe in a line where this needs to get cut on the horizontal bandsaw. So what I'm going to show you guys today is getting the part loaded. Luckily I brought my microphone today so I don't have to do a voiceover. So I'm going to get the part loaded in and show you a couple more things on the Haas control. Okay, so the first step here, I have my parallels already in the vise. Everything is cleaned off in there so there's no chips. We just want to make sure there's no chips in there so it doesn't offset our part. I'm going to get my part in there, press down on it, tighten this, and then I'm going to take my dead blow hammer, give it a tap, make sure both parallels don't move side to side, so we know that that material is down onto those parallels. Okay. The next step is getting our tools loaded into the spindle and then over into the tool changer. So tool 1 is going to be a 3-inch face mill. Remember, I'm going to hold this face mill, I'm going to hold all my tools down by the bottom so that my hand doesn't get drawn up into the spindle. There's a button here that's going to pull our tool up in. We want to make sure that we have these cutouts, these square cutouts, lined up with these drive dogs, these squares on the spindle here. Okay, if we don't have those lined up, it could end up breaking our tool holder here. So that one's up in there. I'm going to then, at the control, turn you guys just a little bit. To bring up tool 2, I'm going to close the door. MDI for manual data input. T2, ATC forward. Open the door. Tool 2 is going to be our 1/2-inch 4-flute end mill. Close the door. MDI, T3, ATC forward. Tool 3 is going to be our 3/8 diameter chamfer mill. T4, MDI, ATC forward. Tool 4 is going to be a 1/2-inch drill. T5, MDI, ATC forward. Tool 5 is going to be a 3/8 diameter drill. Just going to double check the clearance on this one because this isn't a drill chuck holder. Now we might have to switch that tool out into a different holder. But we can go ahead and put tool 6 in, which is going to be a 25/64 drill bit. So once I get all these tools loaded in, I'm actually going to swap out a couple holders here. Once I get all these tools loaded in, I'll go ahead and show you guys how to indicate those tools to the top of our material and then what we have to do with the control at the same time. Okay, got all of our tools loaded in. What we're going to be doing now is we're going to indicate all these tools on the top of our material here. The last tool I've got in is tool 6, so we'll start with that one and work backwards. So the process for this, guys, if you remember, we're going to do a handle jog Z, 0.010 of an inch at a time, and we're going to get the tool close to the top of the material, and then we're going to switch to 1/1000th increments. We're going to put our piece of paper underneath the tool and above the material, I'm going to go click by click, lowering this tool down until I get the tool to grab onto the piece of paper without letting me pull it back out. So there it is right there. Now, to record that position, I'm going to hit Tool Offset Measure. That's going to record the tool height for tool 6. We're going to go to tool 5, T5, MDI, ATC forward. So this drill, you can see, has a very small amount of clearance between the part and the drill, but as they say in the machining world, clearance is clearance. So again, 1,000th increments until I touch the material. There it is right there. I'll record that measurement. So we're going to do T4, MDI, ATC forward. And again, it's just the same process over and over again until we get everything set up. Chamfer mill is tricky because it comes to such a point that it almost sometimes wants to pierce through the paper. So I even take it as slow as I possibly can. This tool has some coolant on it, so I'm going to make sure I wipe that off so it doesn't get my paper soaking wet. Now there certainly is a more efficient way of doing what we're doing. We could be using the tool setter on the table and the probe to be doing all this, but this is a really good way of doing it without a digital system. So, you know, if the batteries, like they often do, go bad in some of our probing system stuff, we still have a way to set our tool heights. Okay, so all the tools are in and set to their respective heights. The next thing is going to be probing the part in, so the machine knows where the part is. So what I'm going to do here quickly is try to focus you guys in a little bit more on the control. So to do that, I'm going to go to Edit, over to VPS, down to Probing, over, down to Work Offsets, over, and I'm going to be probing an outer corner. I hit over. Now, G54 is going to be our back left-hand corner, so we know that for sure. The next thing, we need to select the correct corner. We want corner 4, that back left-hand corner. So I hit 4 and then enter. We can change these, the X and Y travel distances to, say, like 0.5, so it doesn't go as far down our part. And then Z, we're going to change to negative 0.25. Okay? It says F4 to generate the code. We want to generate it to MDI, and there's our program right there for probing. So I'll call up the probe, we'll get it to that back left hand corner, and on MDI we'll hit cycle start. So we want to get the probe in there, we're going to hit T10, MDI ATC forward. I'm going to handle jog that probe to generally in that back left hand corner, just above the part. Okay, that looks good to me. Close the door, go back to MDI, cycle start. Okay, so that recorded those work coordinates for us, but the only problem is in Fusion 360 to get our program set up right, we have some additional offsets that we need to add to that. So I'm going to handle jog in X 10 thousandths at a time, and I'm going to send the part that direction, taking our X offset to 50 thousandths, and then our Y offset sending the part backwards to negative 41.5 thousandths about. Okay, now what I can do at the control, get you guys focused in on that, offset over to work, down to G54X, part 0 set, part 0 set. That sets my new work coordinates on my X and Y axis. And then for Z, I'm going to hit negative 0.02, negative 20 thousandths, and then enter. Okay, so we have the part indicated in, zeroed out. We have our tools in, zeroed out. The next step is getting our program into the machine. I've got to go get the program off of my computer. I'll bring you guys back, getting that on there, and then we'll probably switch to a time lapse while it's machining. Okay, to get our program loaded into the memory, we're going to go ahead and go to list program. We want to get over to USB, so we're going to hit list program again. Scroll over to USB. I'm going to find my program. I believe I named it right peg mount op 1 or operation 1. I'm going to copy that program to the memory, and the importance of that is if I don't copy it to the memory of the machine and somebody goes by and grabs my USB drive out of the control while this is machining, it'll lose the program if we are running it from the USB stick. So we want to make sure we run it from the memory. If I go ahead and click memory, my program is listed there. A couple things to check, right? My tools, there's a tool list right there at the top of the program. T1 through 6. I'm just going to double check that I've got everything in order, right? So I've got a 3-inch face mill, 1/2-inch flat end mill, 3/8 chamfer mill, a 1/2-inch drill, 3/8 drill, and a 25/64 drill. Okay, so those are correct. All right, it looks like everything is good. We can probably go ahead and hit cycle start. So I'm going to switch you guys over to a time lapse while this is machining so this video isn't super crazy long. I'll bring you back in the end when we have finished op 1. Okay guys, so here's op 1 complete. We've got this shape roughed out and holes drilled. I got to tap this hole to a 7/16 by 20. And then we've got to also machine the hat off, the bottom part here on the rest of the material. There is a little post that sticks up. You can see it right here on this stock one. That feature will get machined in op 2. So we do have to end up flipping this over. So it's an interesting thing. You know, we could maybe make some soft jaws or whatever, but this is kind of a weird shape to try to hold on to. So we probably have a couple options here on how to hold on to it, but we'll see what I come up with, and I'll bring you guys back when I come up with a solution here. So hang tight here.